In this section, I will talk about quadratic equations. We're going to talk about how to solve quadratic equations by factoring the square root property, completing the square, and using the quadratic formula. We will also talk about the discriminant to determine the number and type of solutions, determine the most efficient method to use when solving quadratic equations, and solve problems modeled by quadratic equations. A quadratic equation is in the form of ax squared plus bx plus c equal to 0. A, b, and c are real numbers. A cannot be equal to 0. We also call a quadratic equation a second degree polynomial equation. We call it that because the highest exponent in a quadratic equation is the number 2. So that's why they call it a second degree. So now we're going to talk about how to solve quadratic equations by factoring. It is assumed that you know how to factor. So I will show you the steps of factoring, but once again, it's assumed that you know how to factor. To solve a quadratic equation by factoring, we apply the zero product principle, which states that if a product of two algebraic expressions is zero, then at least one of the factors is equal to zero. So for example, a times b is equal to 0. That means either a is equal to 0 or b is equal to 0. Anytime you multiply a number and you get 0, one of those numbers has to be 0. So these are the steps. If necessary, rewrite the equation in standard form, which is ax squared plus bx plus c. Then you're going to factor. Then you're going to apply the zero product principle. You're going to set each one of your factors that contain a variable. You're going to set it equal to 0, and then you're going to solve for the variable. You can always check your answers. So in this first problem, we're going to solve by factoring. It's x squared plus 5x plus 6 equal to 0. So once again, it's assumed you know how to factor. So I'm going to show you my steps on how to factor. So a is equal to 1. A is the number in front of x squared, and you don't see a number, but it will be 1. B is 5, C is 6. So we want to find two numbers that multiply to give you C, and those same two numbers add to give you B. So I'd like to make a table. I want two numbers that multiply to give me 6. Those same numbers have to add to give me 5. Multiply to give me 6, add to give me 5. So I know 2 times 3 is 6. 2 plus 3 is 5. So those are the two numbers that I'm going to use to come up with my factor. So this factors into x plus 2, x plus 3 equal to 0. Next, I'm going to set each one of these factors equal to 0 and solve for x. So you get x is equal to negative 2 and x is equal to 3. When you type it in my math lab, you would type it like this. You will have a, just write, you don't, if you write x is equal to negative 2 and x is equal to 3, it's going to mark it wrong. So you're just going to write it like this, the two numbers. You can always do a check if you want to check to see if this works out. Let's say we check x is equal to negative 2. I'm going to plug negative 2 back into the original problem of x squared plus 5x plus 6 equal to 0. I have negative 2 squared plus 5 times negative 2 plus 6. I want to see if that's equal to 0. So I'm going to put a question mark over the equal sign. So I get 4 minus 10 plus 6. 4 minus 10 is negative 6. Negative 6 plus 6 is 0. So as you can see, negative 2 works out. You can do the same thing for 3. You'll get the same result. In this next problem, we have 2x squared plus x is equal to 1. This is not in standard form, so we're going to write in standard form. So remember, standard form is ax squared plus bx plus c. So I want to get this 1 over here. I want 0 on the right hand side. So I have 2x squared, 2x squared plus x minus 1 equal to 0. So in this case, a is 2, b is 1, c is negative 1. Since I have a number in front of the x squared, I'm going to do something called factor by grouping. Now, you may not know this method. I'm not sure how you were taught. Some people do factoring by trial and error. You do it whichever way you feel comfortable with. So I'm going to multiply a and c. That gives me 2 times -1, which is -2. I'm going to find two numbers that multiply to give me whatever a times c is and add to give me b. So in this case, I want to find two numbers that multiply to give me -2. Those same two numbers have to add to give me 1. So those two numbers would be -1 and 2. The next step is to, and I didn't give myself enough room. Okay, so what we're going to do is, let's see, I know what I'll do. I'm going to move this down a little bit. Okay. So now what I want to do is I want to rewrite the middle term. We're going to rewrite the middle term of bx. I'm going to rewrite this term using the two numbers that I just found. So I'm going to write bx using the two numbers found. So I'm going to have 2x squared minus 1x plus 2x minus 1 equal to 0. And then I have four factors, so I'm going to factor by grouping. I'm going to group the first two, and then I'm going to group the second two. When I look at this first group, it looks like the common term is x, so I can factor out an x. When I factor out an x, I'm left with 2x minus 1. When I look at the second set, the only thing that's common is 1. So I'm going to factor out a 1. Basically, when you factor out a 1, the parentheses, whatever's in the parentheses, just stay the same. So now I have a common binomial factor, which is 2x minus 1. I'll factor that out, and I'm left with x plus 1. So now what I'll do is I am going to set each one of these factors equal to 0 and solve for x. So here I get 2x is equal to 1, divide everything by 2, x is equal to 1/2. Here I'll subtract 1 from both sides, I get x is equal to -1. So my answer would be -1 and then 1/2. So the advantage of factoring is it's great to solve quadratic equations if your quadratic equation is factorable. The disadvantage is not all equations are factorable. So for example, x squared plus 4x plus 1 is not something that you're able to factor. Okay, I have a U-try problem here, and you can go ahead and do this on your own. The answer will be -1/3 and 3. So now I'm going to talk about how to solve quadratic equations by the square root property. Quadratic equations of the form u squared is equal to d, where u is an algebraic expression and d is a non-zero real number, can be solved by the square root property. If u is an algebraic expression and d is a non-zero real number, then u squared equal to d has exactly two solutions. So in order to get u by itself, instead of having u squared, you're going to take the square root of both sides. So I have u squared is equal to d. So in order to solve this, I'm going to take the square root of both sides, which leads me to this. U is equal to the square root of d, and u is equal to the negative square root of d. So let's look at these next problems, and we're going to solve using the square root property. We have 5x squared plus 45 is equal to 0. So I'm going to go ahead and get x squared by itself. So the first thing I'll do is subtract 45. I get 5x squared is equal to -45. and then I want to divide everything by 5. I get x squared is equal to 9. I now want to get x squared by itself, so I'm going to take the square root of both sides. Don't forget to put the positive negative in front of the square root over here to the right. So the square root of x squared is just x. I gotta erase this right here. It's just x. And then the square root of negative 9. You got to go back to your imaginary numbers. We can write this as the square root of negative 1 is square root of 9. Square root of 9 is 3. Square root of negative 1 is I. So this breaks down into positive negative 3i. So you'll get two answers. X is equal to negative 3i and x is equal to 3i. So when you write it, you'll have negative 3i and 3i. Let's look at another one. We have x plus 7 squared is equal to negative 9. I want to get x by itself, so what I need to do is I need to take the square root of both sides to pull that x out. So this ends up being x plus 7. And we already calculated the square root of negative 9 in the previous problem. We get plus or negative 3i. Now we want to get x by itself, so I'm going to subtract 7 from both sides. So I'm going to get two answers because I'm going to split this up. So you get negative 7 plus or minus 3i. So x is equal to negative 7 minus 3i, and x is equal to negative 7 plus 3i. Be careful how you write it in my math lab. This is what the answer would be. I have a U-try problem here. You can try this on your own. You'll get negative 5 as the answer. Now we're going to discuss how to solve problems by completing the square. If you have x squared plus bx, which is a binomial, you're going to add by adding b over 2 squared, which is the square of half the coefficient of x, you're going to get a perfect square trinomial. So x squared plus bx plus b over 2 squared is going to factor into a perfect square trinomial, or a square of a binomial, which is x plus b over 2 squared. So in this first problem, we're going to determine what constant should be added to this binomial so that it becomes a perfect square trinomial. So going back to the rules, we need to take half of the coefficient that's on x. So I'm going to take half of 14, and I get 7. Then I'm going to square that 7 and get 49. So then you have x squared plus 14x. You add the 49. Now this is a perfect square trinomial. And this can be factored into a binomial square. So two numbers that multiply to give me 49 and add to give me 7, add to give me 14 would be 7. 7 is 7. 7 times 7 is 49. 7 plus 7 is 14. So as you can see, you have a binomial. This is just x plus 7 squared. So this would be the answer. So in that problem, we're just learning how to figure out what number you have to square and then add to make it a perfect square trinomial. So now we're going to actually solve a problem that is a perfect square trinomial. Let me see if I can. Alright, so in this one we have x squared plus 4x minus 1. We want to solve this by completing the square. So we want to solve for x. So what I'll do is we want to rewrite it so it's x squared plus bx. So that means I need to get rid of the minus 1. So I'm going to add 1 to both sides. The next thing I'm going to do is I'm going to take half of 4, because that's the coefficient of x. We're going to square it and add to both sides. So half of 4 is 2. And then I'm going to take 2 and square it, and I get 4. So I get x squared plus 4x. I'm going to add 4 to both sides. So now this is a perfect square trinomial. This factors into x plus 2 squared, and this is 5. So now we want to solve for x. So I am going to take the square root of both sides. I end up with x plus 2 is equal to plus negative square root of 5. Then I can solve for x. I'll subtract 2 from both sides. You're going to end up with x is equal to negative 2 plus or minus the square root of 5. So you have two answers. First answer is negative 2. Negative 2 minus square root of 5, and then you have negative 2 plus the square root of 5. So I personally do not like completing the square. It can get very messy if you have fractions, so that's why I tend not to solve problems this way. But you choose the way you feel comfortable with. This is a U-try problem. Once you solve for it, you will get these answers. So the next problem we're going to solve a quadratic equation by using the quadratic formula. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically you're going to take the a, b, and c from your quadratic equations and plug them back into this formula to get your answers. Quadratic formula works for all quadratic equations. So to me, this works for anything. If you have i's in your problem, if you have fractions, whatever, this works for everything. So this is the one I tend to stick with. So in this problem, we have 2x squared plus 3x minus 2 is equal to 0. So my a is 2, my b is 3, my c is negative 2. I'm going to plug all those numbers back into the quadratic equation. So I have negative 3 plus or minus 3 squared minus 4 times a, which is 2, times c, which is negative 2. We're going to divide all of this by 2 times 2, which is 2 times a. And now we're going to go ahead and simplify. So 3 squared is 9. Negative 4 times 2 times negative 2 is 16, all over 4. We end up with 9 plus 16, which is the square root of 25, all over 4. We know that the square root of 25 is 5, all over 4. So you're going to get two answers. You're going to have x is equal to negative 3 minus 5 over 4. And you're going to have x is equal to negative 3 plus 5 all over 4. This turns out to be negative 8 over 4, which is negative 2. This turns out to be 2 over 4, which is a half. So your answer would be negative 2 and 1/2. This next one, we have 2x squared plus 2x minus 1. In this case, my a is 2, my b is 2, my c is negative 1. We're going to plug everything back into the quadratic formula. So it'll be negative 2 plus or minus 2 squared minus 4 times 2 times negative 1 all over 2 times 2. This gives me negative 2 plus or minus 4 plus 8 all over 4. This brings me to negative 2 plus or minus 12 all over 4. And I'm going to break down the square root of 12. The square root of 12 breaks down into the square root of 4, square root of 3 all over 4. And we know that the square root of 4 is 2. So we're going to break this down even further because we have to break down these fractions. So you're going to end up with negative 2 over 4 plus or minus 2 square root of 3 over 4. We're going to reduce these fractions. So negative 2/4 reduces to negative 1/2. And then 2 over 4 here reduces to 1/2. So it'll be the square root of 3 over 2. Okay, because this cancels out. This is a 2 down here. So when you write it, you can't leave it like this. You're going to have to break it up. So you're going to get two answers. You're going to get negative 1/2 minus the square root of 3 over 2. And you're going to get negative 1/2 plus the square root of 3 all over 2. So once you get fractions like this, make sure you reduce it and separate. In this next one, we have 9x squared plus 12x plus 4. My A is 9, my B is 12, my C is 4. I'm going to plug everything back in. We get negative 12 plus or minus 12 squared minus 4 times 9 times 4 all over 2 times 9. Let's go ahead and simplify this. 12 squared is 144, and then 4 times 9 times 4 is also 144. It's going to be a minus 144 all over 18. Well, we know that 144 minus 144 is just going to be 0, and the square root of 0 is just 0. So this leaves me with negative 12 over 18, and this reduces into negative 2 over 3. So as you can see in the other problems, we got two answers. In this particular one, we got one answer. In this next one, we have 3x squared plus 4x plus 2. My A is 3, my B is 4, my C is 2. We're going to plug everything back in. We get negative 4 plus or minus 4 squared minus 4 times 3 times 2 all over 2 times 3. Let's go ahead and simplify this. We know that 4 squared is 16. Negative 4 times 3 times 2 is minus 24 all over 6. 16 minus 24 gives me a negative 8. So in this problem, we're going to have i's as part of our solution. I'm going to go ahead and break up this square root of negative 8 into the square root of negative 1, the square root of 4, square root of 2, all over 6. This gives me negative 4 plus or minus 2i square root of 2 all over 6. Let's go ahead and separate this. This will be negative 4 over 6 plus or minus 2i square root of 2 over 6. We're going to reduce the fractions. So negative 4 over 6 reduces to negative 2/3. And this 2 over 6 will reduce to 1/3. So I'm going to have a 3 at the bottom. And once again, you're going to separate it. So you're going to get negative 2/3 minus I square root of 2 over 3. And you're going to get negative 2/3 plus I square root of 2 all over 3. So this is your final answer. So once again, the quadratic formula works with any quadratic equation. If you have my math lab and it tells you to solve by factoring, or it tells you to solve by completing the square, you don't have to. You can solve by using the quadratic formula if that works best for you. So the next part talks about the discriminant. The discriminant is what you see underneath that square root in the quadratic formula. It's b squared minus 4 times a times c. So we can use the discriminant to determine how many solutions we're going to have and the type of solutions. So if you calculate b squared minus 4ac and you get a positive number, that means you're going to have two unequal real solutions. If the discriminant is 0, that means you're going to have one real solution. And if your discriminant is negative, you're going to have two imaginary solutions. So we're going to revisit the previous problems and just calculate the discriminant. Okay? So we've already calculated this when we did the quadratic formula. If we look at this first problem, we already did this problem, but right now I'm only going to look at the discriminant. So the discriminant is b squared minus 4 times a times c. So that's 3 squared minus 4 times 2 times negative 2. This gives me 9 plus 16, which is 25. As you can see, 25 is a positive number. So that means when we solve this problem using the quadratic equation or a quadratic formula or however you want to solve it with, you're going to get two real number solutions. So that means you're going to get two answers. So we already did this problem. Let's go back up and see what answers we got for this. 2x squared plus 3x minus 2. So that's this problem here. And as you can see, we got two real number answers. Let's look at this next problem. We have 3x squared plus 4x plus, oh no, I think I skipped the problem. Here we go. 9x squared plus 12x plus 4. So A is 9, B is 12, C is 4. We're going to plug everything back into the discriminant. We get 12 squared minus 4 times 9 times 4. We get 144 minus 144, which is 0. Okay? Since the answer is 0, that means we're going to have one real number solution when you solve the quadratic equation. So once we did this already, 9x squared plus 12x, let's scroll up. And that's this problem right here, this last problem here. As you can see, when we did this problem, we got one answer, just as the discriminant suggested. Okay, let's look at this last one, 3x squared plus 4x plus 2. So A is 3, B is 4, C is 2. Plug everything back in. We get 4 squared minus 4 times 3 times 2. That's 16 minus 24, which gives me negative 8. That's a negative number. So that means we're going to have imaginary numbers. We're going to have two imaginary solutions. So when you look at the problem, we did this previously. It's this last problem here. And as you can see, we have imaginary numbers in our solution. Okay, so this is a U-try problem. When you calculate the discriminant, you're going to get 25. So I'm not going to do this problem. So you get 25, which means this is positive. That means you're going to have two real number solutions. And then when you actually solve this problem, you should get an answer of negative 2/3 and 1. Be careful with this problem. You need to rewrite this in standard form. So right now you have a 7 over there. You need to subtract 7 from both sides, so you'll have 0 over here to the right. Next, we're going to talk about the Pythagorean theorem. You've probably seen this before. Pythagorean theorem deals with a right angle. So you have a leg here. This is leg A. You have a leg here. We call this leg B. And we have C, which is your hypotenuse. That's right across from the right angle. So the Pythagorean theorem is a squared plus b squared equal to c squared. So let's look at a word problem. It says a wheelchair ramp with a length of 145 inches has a horizontal distance of 144 inches. We want to know the ramp's vertical distance. So we're going to solve for this x here. So they gave us this hypotenuse. I'm going to call this C. And they gave us one of the legs. We're going to call this B. We want to solve for x. I'm going to call this A. So the Pythagorean theorem is a squared plus b squared equal to c squared. My a in this case is x squared. My A in this case is x, but we're going to square it. B is going to be 144 squared, and C is 145 squared. 144 squared is 20736, and 145 squared is 21025. I'm going to subtract this 20736 from both sides. I end up with x squared is equal to 289. And of course, to get x by itself, I am going to square both sides. I get x is equal to positive negative 17. But since we are dealing with measurements, we cannot have a negative number. So the only answer we can have is the 17. So it'll be 17 inches. Construction laws are very specific when it comes to access ramps for the disabled. Every vertical rise of 1 inch equals a horizontal run of 12 inches. So the ratio would be 1 to 12. We want to know, does this ramp satisfy the requirements? So in our case, our ramp, the vertical is 17 to every 144. So this does not simplify to 1 to 12. Basically, in order to simplify this, you need to figure out what numbers. There are no common factors that will reduce this. You cannot divide 17 and 144 by a number that will reduce it to 1 to 12. So since this cannot be reduced, the ramp does not satisfy the requirement. We're going to do another problem. It says we're going to use the Pythagorean theorem and the square root property to solve the following problem. We're going to express our answers in a simplified radical form. So basically, we're going to come up with a radical answer, but we're going to simplify that. And then we're going to actually calculate out the radical to get a decimal approximation. So in this problem, it says a rectangular park is 8 miles long and 4 miles wide. How long is the pedestrian route that runs diagonally across the park? So this is the park, and they told you that it's 8 miles long, and they tell you it's 4 miles wide. They want us to calculate this part here. I'm going to call this D. So as you can see, this looks like this basically is a right angle, and we can go ahead and solve for D. So I'm going to plug everything back in into the Pythagorean theorem. A squared would be 4 squared, B squared would be 8 squared, C squared, I'm going to change it to D squared. I get 16 plus 30, not 32, it should be what, 64? Is equal to D squared. This is 80 is equal to D squared. We're going to take the square root of both sides. So I end up with D. We're not going to have a negative. This is dealing with measurements again, so we cannot have a negative answer. So we're only going to have the positive square root of 80. But we're going to simplify this 80. This simplifies into the square root of 16, square root of 5, and we know the square root of 16 is 4. So this is the simplified radical form. When we actually calculate this out, when you actually take the square root of 80, you should get 8.9. So these are your two answers. This is the simplified radical, and this is the decimal approximation. So you got to take the square root in your calculator. The last problem talks about a chess tournament. In a round-robin chess tournament, each player is paired with every other player once. The function shown below models the number of chess games, N, that must be played in a round-robin tournament with T chess players. In a round-robin chess tournament, 15 games were played. So how many players entered the tournament? So N represents the number of games, and T represents the number of chess players. We're trying to solve for T. So let's go ahead and plug in our number. We know that n is 15. This is equal to t squared minus t all over 2. We're going to go ahead and solve for t. So I'm going to cross multiply this. When I cross multiply, this gives me t squared minus t is equal to 30 because 15 times 2 is 30. And then I'm going to go ahead and subtract 30 from both sides, and this ends up giving me a quadratic equation. This one is simple. I can go ahead and factor this. I want two numbers that multiply to give me negative 30 and add to give me negative 1. So in this case, this will be negative 6 and 5. Negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. So this factors into t minus 6, t plus 5 equal to 0. I'll set each one of these factors equal to 0 and solve for t. I get t is 6 and t is negative 5. Remember, we're dealing with the number of players. You cannot have a negative number of players. So t is equal to negative 5 will not work. So in this case, your calculations come out to be t is equal to 6 players. So that's how many players entered the game.